All right, gang. I think the final assignment for the week, it'll be a good place to end, is going to be this assignment number 16, which is 4-5 revisited. So far this week, I think we've been mainly graphing the parabolas and stuff, but I want to have things come a little bit full circle, at least a little bit, and doing this like 4-5 revisited thing. And the directions, pretty much say this is a look back at section 4-5, solving quadratic equations, where we only really cared about real solutions, as opposed to imaginary solutions. Remember, in 4-8, you should have learned that we can actually have imaginary answers from a quadratic equation. But with this look back, revisited, I'm going to show you this cool shortcut using technology. Now, you're going to see more attachments than just this. I think you're also going to see like literally this video attachment that I'm making right now. Whoa, I'm like breaking the fourth wall with that. So you're going to have the notes handout, of course. You're going to have this video link somewhere once I'm done making it. And you're going to have the homework copy. So like it says up here, you can like print this out if you want to, or do it on like separate paper and take a pic, if whatever you want, or you could just kind of use this Google Doc, which I'll model for you later. But first, let's actually teach you that shortcut with these notes, okay? So what we're going to be doing here is solving these quadratic equations by graphing. We're going to solve by graphing. Wow, okay. So here, let's see how this works. So I want you to maybe for a couple seconds think about the difference between y equals x squared plus 7x plus 10 and x squared plus 7x plus 10 equals 0. What's the difference between these two equations? I mean, maybe the better question is, what's the connection, right? Because you might look at this and go, well, this is equal to y, but this equation is equal to 0. I mean, that's the basic difference. It's the same equation except one has a y and one has a 0. Yeah, okay. Good eye. Good eye, Brian. What's the connection? Well, okay. This equation, since it has not only an x variable but a y variable, I'm going to refer to this as the function, because this equation actually can be said to represent a function. So I'm going to call this the function. I'm just going to call this the equation. So here we go. There are infinite solutions to this function. There's an infinite number of solutions. All of the solutions are like pairs of numbers, and those pairs will form a parabola in the plane. We've done that. I showed you this week how to graph this parabola in the plane. To elaborate a little bit, since this was in standard form, you would have done like the axis of symmetry formula and then went from there. But we talked about this week how we can graph this quadratic equation and see how it forms a parabola. Now, this equation, there are two real solutions to this equation, because remember, in general, of like any quadratic equation, there's usually two answers, but there also could be one answer, and there actually could be no real solutions at all, which means there would be like two imaginary solutions. So, but for this one in particular, there's going to be two real solutions. Let's see here. Okay, now here's where we make a sort of a big revelation. You ready? Big moment coming up here. These two real solutions, stay with me here. The two real solutions to this equation, all right? How do the solutions to this equation relate to the graph of this equation? Here's a hint. What do you always get when you substitute 0 in for y? Because that's essentially how we go from this equation to this equation. We've substituted 0 in for y. So what do you, in general, what do you always get when you substitute 0 in for y? 5 seconds. What do you get? You get the x-intercepts. You get the x-intercepts. So the bottom line here is, gang, okay, try to get this, downloaded into your brain, okay? The x-intercepts of this graph will be the solutions to this equation. So that's how we can solve this equation by graphing. To solve this equation, we graph this in the plane and we just look at the x-intercepts. And the extra good news here is we're going to take a shortcut to graph these. We're going to use technology. So you can use a graphing calculator if you have one, but you know what's even better than a graphing calculator? Desmos.com. Desmos.com. So that's why I'm going to have this that very website attached to your assignment. So you could literally type in www.desmos.com, click on calculator, or just type in this whole web address, whatever. But if you click on that link, here you go. So here's what we're going to do. We're going to type this in. Now, we're solving this equation, right? And it's equal to 0. But when we type it into Desmos, we have to do the function version of the equation. So we're going to type in y equals this. X squared minus 2x minus 48. So we're going to type in y equals x. Now I'm going to do a caret, right? And that allows me to type in the squared. Now I'm going to hit the right arrow, right? I'm going to hit the right arrow to go down to the regular line, okay? So the right arrow gets me down there, and I forgot what I'm typing in. Minus 2x minus 48. Minus 2x minus 48. And just like this, you have the graph. And you can zoom out. I'm using my mouse kind of scrolling thing. You can zoom out if you need to. You can zoom in as much as you want. You can move the graph around, you know what I mean? But really, all we're looking for here is the x-intercepts. So make sure you've clicked on, you hear me clicking on this, or you can click on the actual parabola curve, right? But Desmos is really neat because all you need to do is hover your mouse arrow, which now it ends up as a little hand here, right? So it looks like one of the x-intercepts is -6 and the other x-intercept is 8, exactly -6 or exactly 8. And so that's why, and so there you go. You can write x equals -6 or x equals 8. Now this next example, x squared minus 3x minus 2 equals 0. Remember, we're going to type it into Desmos with a y equals. So minus 3x minus 2. So I'm just going to change this. Minus 3x minus 2. And here's what I get. Look at that. So now you can kind of just, again, as long as, like when if you accidentally click somewhere, all you got to do is click right back on the parabola or click on the equation up here. So check this out. It looks like this x-intercept is like negative 0.562. Now people, that is an approximation, most likely. And over here, 3.562 comma 0, once again, that 3.562 is probably like an approximation. So that's why I have this approximately equal to in these answers, okay? Approximately equal to negative 0.562, or x is approximately equal to 3.562. So you know what? It's okay to have these answers with this assignment, okay? Now, just a little bit of food for thought, right? If you were to actually solve this the way we would have solved it in like 4-7 with the quadratic formula, this is actually, you know, the answer, to be honest. Like this is the exact answer which you get from the quadratic formula. But guess what? This is fine for this assignment. Absolutely, just kind of getting it from a graph, okay? This next example, x squared minus 4x plus 4 equals 0. Minus 4x plus 4. Oh, check this out. Look at this. Look at this, gang. The parabola only has one x-intercept. It clips the x-axis and then it goes right back up. So it's only touching the x-axis at one point. So this is what the parabola looks like when a quadratic equation, the equals 0 version anyway of the equation, only has one answer. And the only x-intercept is 2. And so we end up with that answer. The final example here, x squared plus 3x plus 5 equals 0, plus 3x plus 5. Plus 3x plus 5. Ooh, let's move, whoa. Let's move this down. Hey, so, check this out, gang. There are no x-intercepts. This parabola doesn't cross the x-axis at all. And, I mean, obviously that's a possibility. I mean, parabolas don't have to cross the x-axis. I mean, here's the proof right here, So when you don't even have any x-intercepts, that's where you can pretty much conclude that there are no real solutions to this quadratic equation at all. In fact, you know what, I probably should have done this thing as well for this one, because when you go ahead and solve this using the quadratic formula, you're going to get imaginary answers. You're going to get the square root of something negative, and you're going to have the I that you bring out. But the bottom line here is, for us right now, is that there are no real solutions when you wind up with a parabola like that. Now I could stop right now, but you know what? Let me show you some freebies on our homework.